The broadcast is now starting. All attendees are in listen-only mode.
Happy GIS Day and welcome to another Directions Mag Geospatial webinar sponsored today by our friends at Hexagon. I'm Barbara Duke, Editor-in-Chief here at Directions Mag with our webinar producer, Lynette Qualia. If you have any questions about your connection, drop us a note in the chat. We'll do our best to help you. Thank you to the geospatial community for being loyal to us for 25 years. Please continue to read and enjoy more content at directionsmag.com. We're taking questions throughout the session today. Type those into the chat at any time. The good folks at Hexagon will follow up with you afterwards for anything that we don't have time to address. Also, snap a photo with your favorite content on the screen with that camera button. We are recording today's webinar, so keep an eye on your inbox for more information in the coming days, and we appreciate your participation in our polls and the post-webinar survey. A warm welcome to Michael, Brad, Danby, and Kyle. They have beautiful examples to share with you today about integrating realistic visualizations into your organization. And we're excited to learn more. Michael, over to you.
Thanks so much, Barbary, and thank you all for joining our webinar on creating immersive experiences with Hexagon and Google Maps. The overall concept of this webinar is talking about new technologies that have arrived from both Google and Hexagon. And what we want to do during the next 25 minutes or so is highlight the complementarity between some of Hexagon's products and some of Google's products using Google inside of our Hexagon products. Just to elaborate on who our speakers are, we have 2 speakers from Google, 2 speakers from Hexagon. My name is Michael Turner, Director of Global Operations for our Google partnership. Danby Lee is the product manager for Google Maps platform, and we'll be talking about the immersive experiences in 3D tiles. Kyle Campbell, Global Product Lead for Geosustainability at Google, and Brad Skelton, the Product Line Director for ERDAS IMAGINE and MapX, will be talking about Google Earth Engine and ERDAS. Just a quick overview to Hexagon. Hexagon is a large global company with operations around the world. We have a very diverse portfolio and a lot of different verticals. Examples include sustainability technologies or geospatial sensors, things like high precision aerial cameras or LiDAR sensors, and also geospatial software. And really what we're going to be talking about today is some geospatial software that integrates and collaborates with Google. Hexagon has been a Google partner for over a decade. As partners, we work in close alignment with Google on a variety of things, including exploring new products. And we're really excited about the new wave of Google Maps products. And we're focusing on Google Earth Engine and the 3D tiles and immersive experiences. But there's some new offerings that have arrived over the last year from Google, sustainability APIs, address validation API, and enhanced APIs for routes and places. Really, as an opening, where did this come from? I think many of you have found that in public Google Maps, there are these incredible 3-dimensional views of many, many cities across the world. And you can also access these beautiful digital twins on your phone. And our customer base, we have been selling Google Maps for years, has been interested in how can we bring Google's fantastic 3D imagery into commercial and business activities. And the good news is this is exactly what's happened. The 3D tiles are now released in general availability, and developers and companies like ours can take advantage of this fantastic new data. If you need more information, there are some terrific blogs on the 3D immersive experiences coming from Google. If you just Google 3D tiles or something like that, you'll get some great additional content. So with that, I'm going to hand it over to Danby, who will walk us all through the details of 3D tiles.
Thanks, Michael. Hi, everyone. I'm Dan B. I'm the product manager for Immersive Maps Experiences here at Google Maps platform, and I'm really excited to chat with you and tell you a little bit about our latest and greatest product, the Photorealistic 3D tiles. So here you'll see where our Immersive Maps products journey really begins, and it starts with imagery for us. Our platform right now offers imagery products in both 2D to 3D for customers that may want more customizability, so those data service layers, to ones that prefer more convenience of use, which are products like the Street View service or even Aerial View. We're also engaged in strategic technology collaborations and partnerships such as this one to accelerate our reach into new target verticals, such as architecture, urban planning, all the way to immersive fan experiences and news media. So last month, our photorealistic 3D tiles became generally available on MapTiles API. As a 3D geodata product, customers can use this as a raw ingredient in creating custom immersive 3D maps experiences at scale. This unique 3D model that you've seen, as Michael has shown in some of our consumer products, is available currently in 2,500 cities around the world, with some plans to grow, and is built at scale with our proprietary photogrammetric methods using a variety of our own imagery data. The map is served in the open source format 3D tiles, which many of you may already know of. That was really driven by Cesium. And this means that customers who have previously maybe struggled to justify the cost of creating your own digital twin or 3D map can now unlock those use cases with just a few lines of code and using this interoperable data format, meaning you can use this 3D tiles in a variety of open source 3D tiles renderers that are already out there. So, excuse me, while the 3D tiles are available at any zoom levels, you can, in your renderer, zoom out to the whole Earth, all the way down to the street. The ideal geographic scale where 3D tiles are most effective are at the city to block scale. So at the city scale, you begin to notice the dimensionality of the map, and the geometry really begins to pop, and you start to see some perspective angles. And then zooming down to the block scale, local scenes really come to life with those 3D objects and shadows rendered between buildings. And at these scales, there are 4 broad purposes that we think our 3D tiles can fulfill for your use cases. So the first is that 3D can really better contextualize a location or a place of interest by providing more realistic views of the world instead of abstracted 2D views. Now, this isn't to say that 2D is completely replaceable. There's always a function and a reason to use a 2-dimensional view. But where you feel that 2D may be lacking in the story you're trying to tell, well, photorealistic 3D perhaps can play that role. These more realistic backdrops can then help end users better locate or navigate through their surroundings. And then taking that one step further, by offering an improved understanding of context, end users can better evaluate how context has or could change over time. So you can imagine visualizing different change scenarios, development scenarios, construction scenarios on top of this, or even going back into the archives and historically telling a story about how the built environment has changed. And then finally, 3D can inspire and help customers tell better stories about our world through maps. So we're already seeing a lot of customers use this in very creative ways. This is an example from BNP Paribas Real Estate, which is a European commercial property company, using our photorealistic 3D tiles to visualize 3D cityscapes. These are then overlaid with the company's information about properties on the market, and it helps urban planners and real estate companies make informed planning and investment decisions. We've also created some in-house demos, and we're happy to share these links. They are in the blogs also that Michael has mentioned, but we have some demos that also show how you can use 3D tiles or photorealistic 3D as a backdrop for information dashboards. This is a quick demo we have for F1, but it can also overlay different pieces of information, charts, statistics, etc., so that you end up having a map-first dashboard as well. So we're excited to see applications such as this also enter into the market. Back to you, Michael.
Thanks, Danby. Really appreciate the overview. The next section, I'm going to show a couple of things that Hexagon has done with these 3D tiles and give you a sense of what needs to happen to bring these tiles to life for your own use cases. The first situation Danby already mentioned is that the tiles are in the open source format of OGC 3D tiles. So it's very easy to see them and get access to them. But you do need a technology for rendering those tiles and adding things like motion and elevation changes dynamically, the kinds of videos that we were showing. So you need a renderer, and Luciad is a versatile viewing technology for imaging these kinds of tiles and creating these kinds of experiences. You can do it inside a web browser, or you can do it inside of other kinds of products. And indeed, Hexagon has embedded Luciad in many of our products to assist with visualization. And last, but very importantly, if you want to get started with using the Google 3D tiles, Google has excellent online, publicly available documentation, and you can just jump in there, get an overview of the product, examples, code examples, and access to how to put the 3D tiles into action. Just a quick follow-up with Danby's discussion of some of the use cases. Real estate obviously is an important one, showed that earlier. The ability to put data on top of the 3D tiles for a variety of reasons, hospitality properties in particular, hotels, a big company understanding which real estate listings may be available. Marketing is another use case that's been opened up by Google, very similar to the F1 example. Elton John did a final tour and built a 3D immersive experience in Los Angeles, showing all the events surrounding the concert and giving people interactive access to that experience. The ability to make tours for visitors visiting different countries and having the ability to sort of pre-scope where you're going. If you're going to Rome, see a little view of the Colosseum and St. Peter's and the river, etc. Planning and development is important. The ability to visualize change and see proposed changes to the landscape. Situational awareness and common operating picture. The notion of having a good sense of what a specific part of the geography might be, where we can see where public safety assets are, where public facilities are, potentially the planning for special events, if there's a parade or a dignitary visiting your city, having a sense of where they'll be and how you can deploy different assets. Pure visualization and 3D maps is just what Google has done with the vast scale of 2,500 cities in 49 countries really creates an available 3D base map. And with some additional technology, you can build overlays that go on top of it, 3D markers and text labels in this 3D space. And right now, I'm going to hop to a couple of videos that show some of this in action. This first video is a fly-through of Zurich. And essentially what you're seeing is the ability to explore this city, to play helicopter driver. But you're also seeing that you can add different kinds of features like the pathway we're following, the names of the different buildings that are there. And as we zoom around, you get a good sense of the landscape. And one of the things that's a little different about this use case is we're now flying into one of Hexagon's office buildings, and we actually have a different 3D twin that Hexagon has created. We have some technology called HXDR that helps create digital twins. And these experiences are seamlessly integrated with 3D tiles, where we're now using a different twin built with other data inputs, including things like LiDAR point clouds and some different capabilities inside of the 3D world, where you can have transparent walls and the ability to walk through a complex facility. So the idea is that 3D tiles can live side by side with all kinds of other 3D interactive experiences. Next one is the Port of Halifax that complements a product that Hexagon is bringing to life called Smart Sites, that is for big complex facilities like ports. And here we see a port, and you can see embedded video. It's kind of the concept of a facilities manager knowing everything that's going on in the port, being able to add GIS layers that overlay in 3 dimensions, the ability to query those layers, and also the ability to hop out of the 3D world. And in this case, it's a port. I think we'll be heading to a NOAA chart. So the port can pull up these charts and look at the shipping lanes where a ship may be coming or going to. And then again, the ability to hop back into the 3D world. And I think this is a great example of how detailed and interesting Google's 3D tiles are. Really brings the port to life as we hop around, and you can see these complex cranes and all the details of the port. At the same time, for situational awareness, it's important to have a view of what's outside of the port. And again, the 3D tiles help us see what's going on in Halifax adjacent to the port, whether it's the ferry terminal, port, different hotels, fire stations, etc. So with that, I think you've gotten a quick tour of 3D tiles and the potential and some of the technology to make this work. And I'll now pass it on to Kyle Campbell, who'll talk about Google Earth Engine.
Thank you, Michael. Hello, everyone. Here to talk to you about Google Earth Engine today. So Google Earth Engine has been around as an experimental platform for about 13 years. And in June of last year, we launched Google Earth Engine as a commercial offering. So what is Google Earth Engine? So Google Earth Engine is a remote sensing platform built on top of Google's cloud. Within the platform, we have a lot of Google knowledge and know-how around maps, our ability to maintain the world's most active and updated map. We have somewhere between 10 and 15 million changes a day that happen to Google Maps. And so a lot of that knowledge and know-how is built into the computation platform within Earth Engine. Along with the computation platform, we have a massive data catalog with over 800 different data sets of imagery and radar type content for analysis. And then finally, the third pillar of the platform is our collaborative ecosystem. So I mentioned Earth Engine has been around for about 13 years. We have many scientists, researchers, as well as commercial users that have been using the platform for a long time that are able to share insights to new users of Google Earth Engine. People always ask me, what is the benefit of using Google Earth Engine? There are other remote sensing platforms out there. You can certainly do remote sensing in other cloud platforms. But really the benefit of Google Earth Engine is outlined right on this one slide here, in that you have the ability to very quickly bring your problem to Google Earth Engine, do the remote sensing without all of the difficult setup. So everything on the left-hand side, provisioning infrastructure, downloading the imagery data, uploading it, working with metadata, clouds and haze, calibrating, things of that nature take quite a bit of time. And the ability to come straight to the platform, leverage the almost 100 petabytes of content that we have in there of imagery, makes it a lot faster for people to solve their problems. And so with this platform, these are some of the more popular use cases that we're seeing with Google Earth Engine. Again, there's a lot of research projects and activities that have been used on the platform for over 13 years. But we do see a lot of people looking to use the platform for sustainable sourcing, the ability to use the imagery that's updated every 15 minutes. We get an upload from either European Space Union, NASA, or USGS, and the ability to look at where all of the goods are coming from. So think about palm, where it's being produced, ensuring that the people that are growing the palm plants are not tearing down forest. So really supporting a greener culture, and that's really at the core of what Earth Engine is all about, being more sustainable. It's also a very powerful platform for climate risk. We have a lot of people in the insurance and finance space that want to look at climate risk against real estate portfolios. Protecting natural resources is definitely a very strong use case area. The U.S. Forest Service is one of the largest users of Google Earth Engine. They use the platform and have been since the mid-2010s to monitor and manage the forests here in the United States. And then we also see people looking at new use cases around environmental impact. One of the real popular areas that's starting to rise up is methane detection. A lot of the satellite data that we're bringing into Earth Engine gives you the ability to determine where orphaned wells are at, or as well as oil and gas facilities that are leaking methane into the environment. So it's a very powerful tool to monitor that. And then finally, and probably the most widely used area is within agriculture, for precision agriculture. A lot of use cases here. We work with many companies, government entities, USDA, to name a few, that have really benefited from using the platform. And so now I'll pass on to Brad to talk more about ERDAS.
We've been so impressed with the capabilities of Google Earth Engine that for our 2023 release of ERDAS Imagine, we've built a bridge between Earth Engine and the cloud environment and then the desktop environment of ERDAS Imagine that we call the ERDAS IMAGINE LiveLink for Google Earth Engine. The LiveLink provides a seamless fit with the ERDAS Imagine Spatial Modeler and provides access to the breadth of the data and the depth of the processing in a no-code graphical environment. So let's start with the data discovery aspect. So on the right, you see the Earth Engine data catalog in a web browser. You can use it to find data, to search for data through their massive amounts of data. When you found one, you can do this. I can just copy the identifier from this, and I can go paste it into Spatial Modeler. Spatial Modeler now recognizes that, creates an operator for it. I can just hook it up like I do with all the Spatial Modeler functions and run it. And when I do that, I got data now that's the entirety of the Netherlands, stylized, etc. In addition to all of the data in the catalog, the LiveLink provides access to Earth Engine processing through the addition of over 800 new Earth Engine operators. So let's take a look at building a familiar algorithm with these cloud-based operators. So on the left, we've got it begun. We're going to finish it by adding in this image divide Earth Engine operator, hook it up, and then let's run this. Let's preview it and see what we get. The computation is all on the fly. It's all interactive at this point. And so now I get a view, I get the data fit to frame. I'm going to zoom in at a 1-to-1. It requests new tiles. I can pan around. It's a compute on the fly environment. So it's very easy to work with, very intuitive, and very much like the Imagine users are used to. But I'm not constrained just to build models that work with data in the cloud. Using the LiveLink, you can build models that combine data and processing from both the cloud with local data. So in this example, we're going to augment an existing parcel feature data set with the average NDVI computed using Earth Engine. So here's my NDVI component again. Here, I'm loading a parcel data set, and I'm going to run a statistical computation on the NDVI per parcel and attribute each parcel with the final result. So let's run this. When we run it, you're going to see that it runs through the Earth Engine part, uploads it to the cloud, then starts downloading the components that it needs to compute these statistics, and then augments the features in the data set. So let's look at the entire NDVI, fit the frame, then we're going to load the feature data set on top of it, and we've got it color-coded for vegetative health. So we've just computed and augmented our parcel data on the desktop with information from the cloud. Now, MapReduce is the Earth Engine paradigm for dealing with collections of tens, hundreds, or thousands of images in a scalable fashion. So this example is going to create that same NDVI, except it's going to do a composite for about 85 images in the California region using Landsat data. So once again, the NDVI pattern down here, but now we're going to use an image collection. In this case, it's a Landsat image collection. We're going to filter that because there's thousands of images in it. We're going to filter it down to those just in the California area, and then I'm going to filter it to a certain date window. For each of those resulting images that are found, we're going to run the NDVI, and we're going to reduce them, put them back together, and then display them. So let's run it. We will get a new view. It takes a moment, and there you go. That's the NDVI run over 85 images that were discovered in the region. Let's put in a backdrop just to make sure that it is. Yep, there you go. It is California. So let's zoom in. And when we zoom in, it's going to recompute at a higher resolution. And this is one of those things that saves a lot of time that Kyle was talking about. I didn't have to go out and research and find all those images. And not only does Earth Engine data span the globe, it spans time. So this model uses the exports to video operator to prepare a time-lapse video of NDVI changes in Australia using MODIS data over several years. Once again, we're going to start with an image collection. We're going to filter it by a series of dates. This is MODIS data, so it's global. I'm going to use this operator, which is a visualization tool. It's going to visualize the NDVI, but I want to put it into a Web Mercator projection that's better than the original projection, and then clip out just the data in Australia. We'll run it through this map operation, which will then give me all the images clipped in a neat stack, and they get handed over to this export to video operation. Now we submit this in batch. It takes a few minutes to run. You'll see it show up on the right-hand panel as a batch job that's waiting. It's gray until it goes green, at which point it's then really been submitted for operation, runs to completion. These results are on the Google Cloud storage area, so we download that, and we can now preview it in the Imagine viewer. And with that, I'll turn it back over to you, Michael. Thank you.
Thanks, Brad and Kyle. Appreciate that. So in summary, we hope we've given you some good information. And the real take-home messages are, Google and Hexagon have complementary technologies. Google's 3D content of 2,500 cities in 49 countries is really a game changer. It creates this global 3D base map to a great extent. And it facilitates a 3D urban base map that can put your own content on top of the 3D tiles. You have a 3D base map and you can drape other content on top. Google Earth Engine and Imagine, as you've just seen, work together in a very coordinated and integrated way. ERDAS Imagine's visual user interface adds value to Google Earth Engine, and Google Earth Engine adds great ability with Google's vast image catalog and the immense processing power. So thanks again for joining the video. I think we have hopefully time.
Maybe a question to our panel. How do you license this technology?
I can take a quick answer at that. Google Maps platform is a family of application programming interfaces, APIs, and Google charges X number of dollars per 1,000 API calls. So if you want to use the 3D tiles, it's an API call that opens up the API so that you can stream the tiles into that, and you pay by the number of APIs that get used over the course of a month.
I can also add some details there. So in addition to that, all of the terms of service and the data use policy is all available on the Google Maps platform developer documentation. So you can Google search that as well, and it should pop up as one of the top search results. So I'd encourage everyone to read that. The TLDR is that it's for visualization use cases, and you can overlay other geodata on top, as you have seen. But to Michael's point, you would need to set up a cloud account, and then from there you'll be able to generate the API key and begin using the tiles directly.
And then I'll add that on the Earth Engine side, with respect to the LiveLink for ERDAS Imagine, that's just a licensed add-on to Imagine and a companion subscription to the Google Earth Engine itself, and it is metered in terms of Earth Engine compute units, and so the subscription provides for a certain amount of those, and when they're exhausted, well, then you re-up on the subscription.
Excellent. Thank you so much. We're going to work in just a couple of quick questions here. How technically complex is using the 3D tiles, and what level of developer expertise is required?
You maybe grab that, Gabby? Yeah, thanks.
Yeah, for sure. It's a very open-ended question. Everyone has a different level of confidence in their programming skills, but generally speaking, if you've already created a 2D map with any of our base map APIs before, using the 3D tiles will be just as easy as that. So the hardest part is just building out the whole UI around it, but integrating with this API is just a few lines of code, and you can choose the render of your choice. There's some that are free and open source and have a lot of documentation around, and in many cases you just kind of grab and play. And others may require a little bit more work, but I've heard of folks in the developer community who have stacked up simple visualization within a few hours.
Yeah, let me add to that with our Luciad RIA SDK, which is a JavaScript SDK for embedding these things in browsers. It supports the 3D tiles. I know that it's a very straightforward operation, and similarly, somebody using that SDK, if they're a good JavaScript programmer, can, using the samples, be up in just a couple of hours to have something running.
That's great news for a lot of people. So one last question: how can they learn more about all these great resources?
Well, I will start with one on the ERDAS Imagine side, the Hexagon web page. You can drill down into the product section, and this LiveLink is one of the add-ons to ERDAS Imagine. So you just navigate your way to the ERDAS Imagine page, and there's a whole lot of information there about it, including a brochure, and I believe we have a video about it out there now. So there's lots of information about that.
Yeah, and as I mentioned earlier in the presentation, Google has fantastic developer documentation, and just Googling phrases works very well to find the developer documentation. So if you do something like Google Developer Documentation 3D Tiles, you'll get right to the right page, and it opens up a real treasure chest of good information for getting started, for understanding the terms of service that Danby mentioned, and even code samples.
That is great news. Big thanks to Hexagon and Google's teams for sharing their expertise. We hope to see you at more geospatial webinars. Have a wonderful rest of your GIS day, and tell a friend about Hexagon, Google, and Directions Magazine. Thanks, everybody.